And we are moving right along with our statistics unit with video 2.6, the 5-number summary. You have quite a bit of notes in this video, so make sure you are ready to take them all down. It's a pretty simple process, but it's very important for our next skill that we'll be learning, which is how to make box plots. So some vocab you need to get down. First of all, what is the 5-number summary? Well, it describes the 5 most important percentiles of a distribution. Number 1 is the minimum, the lowest value. Number 2 is the first quartile, which has the first 25% of data. The third is the second quartile, which is the median or shows 50% of the data. The fourth is the third quartile, or 75% of the data. You can think of quarters. 1 quarter is 25%, 2 quarters is 50%, 3 quarters is 75%, and then we have number 5 is the maximum or the highest value. And then the other term you have to get down, which we'll be going into farther in another slide, is the interquartile range, or the IQR. And that range shows us the middle 50% of data that we can make predictions about, analyze, and help us describe our distribution even further. And you get that by taking quartile 3 and quartile 1, subtracting them, and that will equal the IQR, or interquartile range. So how to calculate the 5-number summary? We have this problem here, and we're going to use this for the whole video. The ages of 9 cousins at a family reunion is shown below. It should say are shown below. Okay. The minimum, the Q1, the Q2, the Q3, and the maximum. In this slide, we're going to do minimum, Q2, and maximum because they don't require any calculations. All we have to do is put our data in numerical order. Just like when you find the median, it needs to be in numerical order. So we'll start with 4, next is 6, 7, 8, 10, another 10, separate all of them, 12, and then 2 15s. And let me just make sure I did that correctly. I should have 9 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So the minimum we can see right away, it's the smallest value. So our minimum is 4. Q1, we'll get into next slide. Q2 is the median. Well, I just need to find the middle number. And if there's 9 data pieces, I know that my middle number will be the 5th number. So my median is 10. And then my maximum, Q3 we'll do on the next slide too. My maximum is the highest number. So 15. Minimum, Q2, or median, and maximum. Pretty straightforward for finding those 3 numbers. Make sure you have that down, and now we're going to find Q1 and Q3. So in order to find Q1 and Q3, you need to find the median of the first half of data, as it says right here, and then for Q3, you need to find the median of the second half of data. And this does not include the median of the entire set of data. So we are going to block off that median since we have an odd number. And if we were to have an even number, let's say that our data set was 4, 6, 7, 8, 10, 10, 12, and 15, we would draw a line down the middle because that's where our median would be, and we wouldn't count it. But since we have an odd number, we're not going to include the median in our first half or second half of data. So let's look at the first half. I need to find the median of the first half of data. I have an even number in my first half. So I need to take the mean of my middle 2 values, and the mean of 6 and 7 is 6.5. So Q1 is 6.5. And then I need to do the same thing for 12 and 15, find the mean. So my mean for 12 and 5 is going to be 13.5. So now I have my 5-number summary. I have my minimum of 4, my Q1 of 6.5, my Q2 of 10, my Q3 of 13.5, and my maximum of 15. And you may be saying, well, why are we finding these 5 numbers? When we make box plots tomorrow, you're going to see how necessary it is to be able to find these 5 numbers. So a little bit more, the interquartile range is another way to describe your data, and it's, remember, the middle 50% of data. So you find the interquartile range by subtracting this should say subtracting Q1 from Q3. And we have Q1 being subtracted from Q3. So our interquartile range is 7. And what we can do with that number 7 is find these things called outliers. Outliers are data points that are much smaller or much greater than the bulk of data. Let's say that on a quiz, everyone really bombed it and they got like 50s and 60s, but then there's one person who got a 100. That would be considered an outlier. But you can specifically classify outliers by using these formulas right here. So get those down. To find outliers that are much smaller or much larger, you have to do these two formulas. You take Q1 and you subtract the IQR, which is 7, times 1.5, and then you would add that same IQR times 1.5 to quartile 3. So we're going to do that for our data set we found today and see if there are any classified outliers. So the first thing I need to do is fill in my formula for Q1 minus IQR times 1.5. So Q1 is 6.5. I'm going to subtract 7 times 1.5. Now we have 6.5 minus 7 times 1.5 is 10.5. So that is negative 4.5. And obviously we can't have a negative h, so there are no outliers in the lower set of our data because there is nothing below negative 4.5. Now let's see if there's anything above as an outlier. So we have 6.5 plus 10.5 because we know that we do 7 times 1.5, and that would be 17. And we have no data that is above 17, so there are no outliers in our data set, but that is how you would try to find them if you were to have outliers in another data set that you're working with. So your hot question is, what is the 5-number summary and IQR for the following data set? In your 5-number summary, when you put it in your hot question, I want you to label min, Q1, Q2, Q3, and max, and then label IQR. Enter that for your hot question, and we'll work on this skill tomorrow.